Hey, good morning. Oh my gosh, Miss Collins, why are we doing this? My little breadcrumbs. I love you so much that we've got to keep growing those brains. And so we are going to move on to ratios. I love ratios so much. You may not, but I do. And I love teaching. Okay. So we're going to keep going with ratios. So the question is, what is a ratio? Well, a ratio is a comparison of two quantities. Okay. So ratios can compare part to whole, or whole to part. And so here's some examples. The ratios below describe relationships among the pieces of fruit to the right. For example, I have 4 apples and I have 2 bananas. So there are 2 bananas to 4 apples. There are 4 apples to 6 pieces of fruit. There are 6 pieces of fruit to 2 bananas. So this is where we have part to part. Do I have to write this down, Miss Collins? You sure do. Okay, just to give a comparison. Part to whole, okay, and then whole to part, okay. So when we write ratios, it looks very similar to fractions because remember we're comparing two quantities. Given quantity A and quantity B, the ratios of A to B can be written in 3 ways. So you can write it as a fraction, A over B. You can write it with a colon, A to B, or you can write it with the word A and then 2B, okay? So as we move on to right ratios, we have right here a grid, and we have part of it shaded, and we're going to write this as a ratio. So what they're asking you to do is shaded squares to unshaded squares, and we're going to write every way so that we can be practicing and looking towards mastering that skill. Shaded, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. And when I've taught this in the past, kind of like when we're doing writing our expressions, writing our equations in the word form and putting it in numerical form, writing that above the strategy to remind myself how many I've got, okay? Unshaded, 1, 2, 3, 4, 5, 6, 6. So we would say 10 to 6, 10 to 6, and then as a fraction, 10 to 6. Oh my gosh, Miss Collins, it's improper. That's okay. That's okay. We're just comparing. Unshaded to total. Well, you don't have to recount. Come back up here. Unshaded was 6. To total, 1, 2, 3, 4. By 4 by 4 is 16. So 6 to 16. 6 to 16. And then 6 to 16. Total squares to shaded squares. 16 to shaded squares, which is 10. So 16 to 10, 16 to 10, 16 to 10. Unshaded to shaded. So again, unshaded is 6. Okay, shaded is 10. 6 to 10, 6 to 10, and then 6 to 10. Okay, I'm going to pause for a second. I need to drink some water. I gotta drink some water. Pause. Whew, needed that water. So now we've written them. Now we're going to simplify ratios. Remember way back in the beginning when we did greatest common factor, and I said it was going to haunt us? It's going to haunt us. Okay? But it says like fractions, ratios can be written in simplest form. So you need to find the greatest common factor of the numerator and denominator. Divide both the numerator and denominator by this number. Now, remember when in January, I know that's many moons ago, when I gave you the greatest common factor paper of all these numbers, it was a gift. It was a gift. I'm going to pull mine out right now. Remember this bad boy? Yep. So you don't kill all your time. Go in there, pull it out. What is the greatest common factor of 8 and 12? So if I'm looking, 8 has 1, 2, 4, 8. 12 has 1, 2, 3, 4, 6, and 12. So it's 4. So we're going to divide my numerator and my denominator by 4. And I'm going to get 2 over 3. But I'm not going to say 2 over 3. It's going to be 2 to 3. 2 to 3, 2 to 3, 2 to 3. Okay, so now we're going to do, again, writing each ratio in simplest form in 2 different ways. So this is the 3. You only have to choose 2. So I have 6 red bows to 12 green bows. Now, please understand, when you are writing ratios as this, you need the first thing in your comparison that comes up, the first number is going to be your numerator. If you're going to use fraction form or any of your forms, that will be the first numerator, first integer, whole number, whatever number you have. Okay, so I have 6. I'm going to write in fraction form this one to 12. Okay, and then, oh, I forgot. We're going to do this real quick as a fraction because we have to write in simplest form. So the greatest common factor of 6 and 12, go back and look at your paper. It's going to be 6. So I'm dividing my numerator and denominator by 6, and you're going to get 1 to 2. So this can be one of your forms, and then you can do another one. 15 horses to 20 cows. 15 is your numerator, 20 is your denominator. And if you go back and look at your paper, 15 and 20, the greatest common factor is 5. Okay, so we divide both by 5. Okay, and then you get 1 to 4. And then I'm going to write it this one, 1, 2, 4. Okay, so make sure you have that written down and take a sip of water if you're still writing down. All right, so continuing on, we have 20 children to 4 adults. So again, don't just try to put your smaller number on top. It's going to be the first one present, 20 to 4. Now, you are not going to do 20 divided by 4. Some of you are thinking, oh my gosh, it's going to be whole number 5. No. You're going to look for the greatest common factor of 20 and 4, and it is 4. So 20 divided by 4. 4 divided by 4. 20 divided by 4 is 5. 4 divided by 4 is 1. This is okay. Do not put 5. Okay? We're not simplifying a fraction. We're simplifying a ratio. So you have 5 to 1 and then 5 to 1. So what this really means simplified is 5 children to 1 adult. 14 nurses to 6 doctors. Going to look 14 and 6. It's 2. Man, Ms. Collins, I love it when I have these notes. I just power through it. 14 divided by 2 is 7. 6 divided by 2 is 3. So 7 to 3 and 7 to 3. So 7 nurses to 3 doctors. See? 16 quarters to 72 pennies. I don't know if I did up to 72, guys. Let's see. Ooh, I did. I'm so awesome. Everything is so awesome. Yep. 4. 4 is the greatest common factor. 16 divided by 4 is 4. 72 divided by 4. Now, some of you are like, oh, Ms. Collins, you have a calculator, or remember our little rainbow method. Since we wrote them in order, 1 goes with this, 32, 3, 4 is 18. Okay? So 18. 4 to 18. Guess what? Guess what? I'm wrong. Am I? Oh my gosh, I'm wrong. 8 is the greatest common factor. And you know how I know that, guys? Remember, when you do the greatest common factor of two integers, and then you see that there is still a common factor greater than 1, we didn't simplify it all the way. Way to go, Collins. Let's try that. 16 divided by 8 is 2. 72 divided by 8. So I'm going to go back to my rainbow method. Oh, I'm not. No, I'm not. No, I'm not. That's a compatible number. 72 divided by 8 is 9. I can't believe I did that. And then 2, 2, 9. So 2 quarters to 9 pennies. Okay. I have 18 necklaces to 15 bracelets. Looking again. 15 and 18. It's looking like 3. Divided by 3. Divided by 3. 18 divided by 3 is 6. 15 divided by 3 is 5. And then I have 6, 2, 5. All right. Oh, this is stinky. It's a tricky one. You're like, oh my gosh, Miss Collins. So vowels to consonants in the word dictionary. That's what I'm saying. Okay, well, how many letters are in the alphabet? If you see my, remember my sign up here in the back of my room, it says if plan A fails. I wonder if y'all can see this. No, not me. You don't want to see me. No. Still don't want to see me. But see back there? See back there? How do I? See it back there? Right back there. See it? You can barely see it, but it says if plan A fails, there are 25 other letters in the alphabet. So, oh my gosh, Miss Collins, there are 26 letters in the alphabet, in the dictionary. But how many of those are vowels? Okay, A, E, I, O, U. 5. So 5, 2. And then when they say to consonants, you need to take that whole, because part is vowels, part is consonants. So we're doing a part-to-part ratio, but the whole is 26, and you need to subtract your vowels. So 26 minus 5 is 21. Okay, guess what? Well, if I were to go and look at the greatest common factor of 5 and 21, I know that it's 1. Okay, because there are 2 factors for 5. 5 is prime, so it has 2 factors, 1 in itself. And then 21 has multiple, but the only one they share is 1. So therefore, this is simplified. Okay? So girls to total number of students in our class. So you're all going to be seeing this, both classes, and it's going to be different in both classes. So while we're in class together, we'll do this together, but obviously we can't do it in our video. Okay, so here's some applications. Like we're applying this to real world. Yay! Out of 75 students, that's my whole, 36 buy their lunch. What is the ratio of students who buy their lunch to students who bring a lunch? Oh. Let me grab my calculator. If you don't have yours, grab it. This is a thinker. Get my thinking caps on. Hot dog sauce. Okay. All right. So the whole is 75. We have 75 students. 36 buy their lunch, but the ratio is students who buy their lunch, which is 36. Okay. To students who bring a lunch. Ms. Collins, I don't know what that is. It doesn't tell me. I know. We had to 75 our whole. That's everybody eating lunch, but we got to subtract the kids who buy lunch. So This many kids, 39, bring a lunch to school. Okay, and we need to go look at those greatest common factors, 36 and 39. 3. So divide both by 3 because we are simplifying. 36 divided by 3 is 12. Right? Yep. Yepperty deppers. 13. So we'll have 12 to 13 or 12 to 13. Okay? 14. This week, Ariel worked 16 hours at the grocery store and 24 hours at the library. Write a ratio of the number of hours she worked at the library, okay, which is 24, to the total number of hours she worked in simplest form. So we're going to do part to whole. So to find out all of the hours she worked, we need to add 16 and 24 together. 40 hours. Look at that, a solid work week. All right, but now you got to simplify that. So let's find the greatest common factor while I take a sip. Looks like 8. 8 is the greatest common factor. So 3 to 5 or 3 to 5. Okay? Number 15, the table to the left shows, ooh, we got tables, but what tables don't get this thing over. The table to the left shows the number of miles Joe ran, walked, and cycled last week. Oh, what a solid exercise. Give the ratio of the number of miles he ran to the total number of miles in simplest form. So, the number of miles he ran. I'm going to just underline that. Number of miles he ran. Let's go back over here. 15. To the total number of miles. So we're going to add these up. I'm not going to be a superhero and do it in my head. I'm going to be accurate and do it on calculator. 50. So now I got to go over here and find the greatest common factor of 15 and 50. 5. I have 3 to 10 and 3 to 10. 16. In their last game, the Packers scored 4 less than twice the number of points that the Seahawks scored. Miss Collins, oh my gosh. Look what they're doing to us. If the Seahawks scored 16 points, write a ratio for the number of points scored by the Seahawks to the total number of points scored by the Packers. To the number of points. Okay, so let's just start simple because I know you're all like, help. 16, okay, because we're doing number of points scored by Seahawks. Okay, 16. So let's look at this right here because this is a good one. Oh, it's a good one. So the Packers scored 4 less than. Remember, when we have less than, it switches. Then twice the number of points the Seahawks. What did the Seahawks score? 16. So I'm gonna come over here, and I have 4 less than. So something minus 4, and then twice the number of points. So 16 times 2 minus 4 is basically what we're doing. 16 times 2 is 32. And then I have 32 minus 4, and you get 28. Okay. Whew. That's a good one. So then I'm going to go look at the greatest common factor of 16 and 28. Divide by 4. Divide by 4. 16 divided by 4 is 4. 28 divided by 4 is 7. So 4 to 7. And 4 to 7. Oh, I like that one. A jar contains 13 pennies 9 nickels, 10 dimes, and 8 quarters. What is the ratio of coins worth at least 10 cents to the total number of coins? Ooh. Okay, coins. So what I'm saying, it's not. If you have 13 pennies, each penny is worth 1 cent. I know together it's 13 cents, but I want what an individual coin is worth. Pennies are worth 1, nickels are worth 5, but the ratio of coins worth at least 10 cents. I have 10 dimes and 8 quarters. So this little group, 10 plus 8 is 18, because that's the group of coins that are worth at least 10 cents. Okay? Kind of hear that inequality in there, right? To the total number of coins. So part to whole. So I have 18 and then plus 9. So 18 plus 9 plus 13, and we get 40. 18 to 40. That was another good one. Greatest common factor of 18 and 40. Ew. Don't be difficult. Ew. It's just 2. So divide numerator and denominator by 2. And you get 9 to 20. Or 9 to 20. Last one. I know you're all like, yippee skippy. A bag contains 20 slips of paper numbered 1 to 20. Okay. What is the ratio of prime to total numbers in simplest form? Oh my gosh, I love that. I love that. Well, you should be able to look at your factor paper and figure out, well, I don't remember what prime is, Ms. Collins. Oh, well, remember, your prime numbers have 2 factors, one in itself. So look at all those that you have through 20. 1, 2, 3, 4, 5, 6, 7, 8. You have 8 prime numbers. So prime numbers, 8 to the total numbers. Well, we have how many? 20. Ms. Collins, what about 1? Remember, 1 has 1 factor itself. It's neither prime nor composite. So let's greatest common factor the mess out of this. 4, 4, and 4. So 2 to 5. That's it. That's it. Love ratios, and so will you. Stay tuned for the homework video.